Okay, circle all the number sets for 6.2. So 6.2 is a decimal that stops. Okay, I could also write this as a fraction, so automatically that's a rational number. So if it's rational, it's also real, so it's not a natural whole integer or irrational number. -5 is a positive or negative whole number, so it's not a whole number because they can't have negatives. Natural numbers can't have negatives, so it's an integer, which makes it rational and real. Okay, true or false? An integer is always a whole number. That is false. And I'm going to give a counterexample if I find something to be false. So -5. -5 is an integer, but it's not a whole number. A rational number is always always an integer that's false, because 6.2 is a rational number that's not an integer. Some whole numbers are natural numbers. That's true. So some means, a few or more. So 1, 2, 3 are whole numbers that are also natural numbers. Every whole number is a natural number. That's false. Okay, because the counterexample would be 0. Some rational numbers are whole numbers. That's true. Okay, some rational numbers, 3, 6, 12, those are rational numbers. They're also whole numbers. Okay, number 8. When you have to evaluate, it means that you need to plug in the number for x and put it in parentheses. So -3 times -2 squared minus 5 times -2 plus 2. And then you just order of operations. Okay, you can just plug this in your calculator too. But this is going to be -3 times 4 plus 10 plus 2. So this will be -12 plus 10 plus 2, which is 0. Okay, for letter B, we're going to plug in -2. So remember, you're plugging it in parentheses. Okay, order of operations would have you do -2 squared first, which is actually a positive 4. This is positive. This will be -4 minus 14, which is -18. Okay, letter C, plug in -2, so it's -2 plus 2. Well, -2 plus 2 is 0, and the absolute value of 0 is 0. Okay, simplify. So simplifying, we want to do the distributive property. So 3x, and I'm going to distribute the 3 through. So it's going to be plus 3x minus 6. So 3x plus 3x is 6x, and then minus 6. You cannot go any further with this because these two are not like terms. And then letter B, you want to distribute the negative through. So it's going to be x plus 6x, negatives x, and then positive 3, because a negative times a negative is a positive. So then I'm going to add the coefficients. So I have 1 and -1. Those are going to cancel out. So my answer is going to be 6x plus 3. And then letter C, I'm going to do the distributive property on the first part and second part, and then I'm going to combine like terms. So the first part is -3x minus 9. The second part is going to be -4x minus 20. And I'm going to add these two together. So it's going to be -7x minus 29. Okay, simplify, combine like terms again, add the same coefficients, and you want to answer in alphabetical order. So x's go first, so I have 6 x's, and then I have -9 y's. Here I have -1x and -1x, that's -2x, and I have -y and -y, and that's going to be -2y. Okay, for solving equations, what you want to do is get your x on one side. So this is a positive 4x, so I'm going to subtract 4x. So I'll have x plus 3 equals 10. And then I'm going to subtract 3 from each side to get x equals 7. And you really should plug in 7 in for x and see if the left-hand side is equal to the right-hand side. And b is going to be -x minus 3 equals negative 2x minus 4. So I'm going to add x to each side. So I'll have negative 3 equals negative x minus 4. And I'm going to add 4, so 1 equals negative x. And I'm going to divide by negative 1, so x is 1. C, I'm going to subtract 3x from each side. So 6 equals 6x minus 9. Add 9, 15 equals 6x. And divide both sides by 6. So 15 divided by 6 is going to be 5 halves. If I divide the top and the bottom by 3, or you can put 2.5. 5 over 2 is the same thing as 2.5. Okay, solving for variables. So solve for x. So what's going on here is you have x times y times, or x times w times y. This is all multiplication. So I'm going to divide. So x equals z over wy. Okay, b, if I have to solve for x, I need to get rid of this a, and this a is being added. They're not together for multiplication, so I need to subtract a from each side. So x equals b minus a is going to be my solution. And then c, this is x divided by b. The inverse of division is multiplying. So I'm going to multiply both sides by b to get x equals by. Okay, to solve for x in letter D, what you want to do is you need to get rid of the b's. So you're going to multiply both sides by b, and the b's will cancel out. So you have 3x equals by, and then I'm going to divide both sides by 3. So x equals by divided by 3. Okay, for letter E, to solve for x, you have to get rid of the y first. So I'm going to subtract y from each side. So it's going to be 2x equals z minus y. And then I'm going to divide both sides by 2. So you can write it as x equals z minus y divided by 2. Or you can divide each term by 2. Z divided by 2 minus y over 2. And then for f, I'm going to get rid of the 1/3. So I'm going to multiply both sides by 3. So it's going to be 3y equals xz, and then I'm going to divide both sides by z. So x equals 3y divided by z. Okay, now solve and graph each. So for inequalities, you want to isolate x, and then, so I'm going to subtract 3, so it's x is less than or equal to 9. So it's going to be a closed dot at 9, and numbers that are less than 9 are going to the left. For b, I'm going to multiply both sides by -2. That's going to get rid of the negative and the 2 in the denominator. So remember, if you multiply by negative, you have to change the direction. So it's going to be x is greater than -6. So it's going to be an open dot at -6, shaded to the right. Okay, letter C, I'm going to subtract 5. So 4x is less than or equal to -16. Divide both sides by 4. I'm dividing by a +4, so I don't need to switch the inequality. So it's going to be solid dot at -4, shaded to the left. Okay, so I'm going to simplify the left-hand side. So -x plus 2x is x. Then I'm going to get my x's on the same side. So in this case, I'm going to subtract x for me. So 0 is less than 12 plus 3x. You might do it a different way though. So I'm going to subtract 12. So -12 is less than or equal to 3x. Divide both sides by 3, and I get -4 is less than or equal to x. So another way I could write this is x is greater than or equal to -4. Okay, see how there's Pac-Man's biting x right here and Pac-Man's biting x right here? So those are the same thing. So I'm going to put a closed dot at -4 and shade to the right. Okay, letter E, I'm going to distribute, so it's going to be 3x plus 6 is less than 3x plus 6. So subtracting 3x from both sides gives me 6 is less than 6. Okay, 6 is not less than 6, so that's a false statement. So remember, if it's false, it's going to be no solution. So on a number line, you would have nothing to graph because there's no solution. Okay, letter F. I'm going to get my x's on the same side. Okay, this time I have 8 is greater than or equal to 2. This is a true statement. So this means that I would shade everything because the answer is going to be all real numbers. No matter what you plug in for x, a real number, the statement is going to be true. So everything is shaded on the number line. And then G, this is a compound inequality. This is an and right here. So I'm going to look in the middle and solve for x. So I'm going to subtract 1 from all three parts. So I have 9 is less than 3x is less than 15. Then I'm going to divide everything through by 3. So 3 is less than x is less than 5. So I put open circles at 3 and 5, and I shade between. Okay, letter H is an or, so I solve each of these separately. So it's going to be x is greater than negative 3 because I divide by a negative, or x is greater than 10. So x is greater than 10, or x is greater than negative 3. So everything that's shaded is actually going to be x is greater than negative 3. Because when you have an or, you're looking at where anything is shaded. If you have an and, you're looking at where they overlap. Okay, I have another or, so I'm going to subtract 7. So negative 5x is less than or equal to negative 5. I'm dividing by a negative, so I've changed the inequality. So this is 1. So I have x is greater than or equal to 1, or x is less than negative 10. That's going to be an open dot to the left. Okay, a couple more. So this is another and where I'm going to solve in between. So I subtract 6 from each side. And then I'm going to divide everything through by 3. So it's negative 6 is less than x is less than equal to 9. So I'm going to shade in between negative 6 and 9 and make sure they're both closed dots because these are both equal to. And then the last one, I have an or. So it's going to be 5x is less than 0, x is less than 0. Because I subtracted 10 from each side, or divide by negative 6, x is greater than 6. So I switched the inequality because I'm divided by a negative. So x is less than 0, or x is greater than 6.